Hi everyone, and welcome to our video on graphing rational functions using a calculator. And I'll be using Desmos since it's the most convenient for the online videos service here. All right, so to graph these though, first thing I will do, these first three steps, let's go ahead and find these by hand for practice, because it usually wants these for other things too, and these are faster by hand anyway. And then we'll verify it with the calculator too. Okay, but for number one, finding the vertical asymptotes. All right, so vertical asymptotes occur when the denominator equals 0. So that means I just need to take my function's denominator and set it equal to 0, and then solve. Well, all I have to do is subtract 5 to solve, and that would give me x is -5. Okay, so there's my vertical asymptote, which we'll show in our picture when we start to graph. The second thing we need is the horizontal asymptote. Okay, let me put that right here, number 2. Okay, so the horizontal asymptote is when we compare the degree of our polynomial's numerators and the polynomial's denominator there. Okay, so the whole thing's a rational function, but this is a polynomial up top, this is a polynomial down below. Notice they are the same degree. They're both degree 1. Okay, so I'm going to mark it right here, same degree. And then so that means we'll use our rule, which is to take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. And then we'll just simplify, which would be y equals 2. Okay, so there's the horizontal asymptote. And then our third step is to find the y-intercept. So the y-intercept for any function is to let x equal 0. So that just means plug it in to 0 for all your x's. So f of 0 would be 2 times 0 plus 5 over 0 plus 5. 2 times 0 is 0, plus 5 is still 5. 0 plus 5 is 5. So we get 1 when it's all simplified. And that means our x-coordinate was 0. So let me write it right here. Y-intercept was 0, 1. Okay, so there's the most important stuff for our rational function. And then let me go ahead and get this started. So here's our x-axis and y-axis. All right, and I'm going to go ahead and let's go ahead and use some tick marks on this. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so just to get try to get a little scale to it. All right, and then what I want to do is graph these things. So the asymptotes, I'm going to graph in the purple. Usually we show these as dashed lines in our graph. So before I even go to the graphing calculator, let me graph what I currently have. So x equals -5 means to go to -5 on the x-axis. Here it is. And then from there, draw in a vertical line. But, again, dashed, because it's not really part of the graph. It's just going to help show how the graph moves. It's going to show where the graph goes. Okay, so there's that one. And then y equals 2 is go on the y-axis and find 2. And then from there, draw in a horizontal line. But like the other line that we just did, keep it dashed, because it's not really actually part of the graph. Again, it's just going to help show us how to draw the picture. Okay, and then we'll do our final graph in blue. So let me graph the y-intercept as 0 and 1, which is right there. Okay, so there's the everything without a calculator. Now, in the calculator, I'm going to use Desmos. Again, I already got it pulled up. So desmos.com and then /calculator, or you just go to Desmos and do the graphing calculator. And then we're going to type it in exactly as we see it. Now, if you have an 83 or 84, this is where you would need parentheses depending on how old your calculator is. So you could so I'm going to do it with parentheses, where I put the parentheses around the numerator and then divide parentheses around the denominator. Okay, so because this one automatically makes the big fraction, but some calculators don't do a big fraction. So that means they might do like the slash. Okay, so instead of the big fraction. So that's where we need those parentheses around the numerator and denominator to be extra safe. Okay, and notice on our graph, okay, so it looks something like this, and it gives us two important points. One we already had, 0 and 1. Here's another one that's useful for us, the -2.5 and 0. And then notice as we zoom out, well, it looks something like this. So let me zoom back in and show our graph. All right, so actually let me zoom out a little bit and let me click on it and show as I go to the right, notice the y-coordinate is getting close to 2. Okay, so it's very, very slowly, but it never will. Okay, 1.9, so forth. No matter how far right I go, so that's why we put those asymptotes in. So it's showing this graph is kind of going toward that asymptote. And similar with my vertical asymptote, notice my x-coordinate is getting close to -5, but it will never be -5. Okay, so here's our line of -5. So look at that. It gets very close the whole time, but it never will be, no matter how far I zoom out. Okay, so that's why we put in those asymptotes before we did this in the calculator. Okay, anyway, so that's all I have to do is kind of sketch this along with what happened with the asymptotes. If I need other points, I can find them. Okay, so like if I plugged in -6, or if I use my table option, so I can see like -6 would be 7. So that means I could try to make it more accurate on my grid. Okay. However, let me go ahead and get our final sketch. So the only kind of things I wanted, let me add that -2.5 and 0 point that we found on the calculator. And then all I'm going to do is draw it in like that. So I want to get close to the asymptote, but not touch it or cross it. Same deal with that. There we go. And then in our picture, we saw we had something like this right there. Okay. Okay, and if I wanted to, so let me see how accurate I was there. I think it was pretty close. 1, 2, 3, 4, 5, 6, 7, and there, yeah. So I was pretty good on my drawing, I think. So there was -6,7. That was from that table. There it was. Okay, anyway. So if it's on a grid, we can make it more accurate, but often we're just trying to make quick sketches anyway. Okay, so there it is. So there's our sketch using the rest of the calculator, along with finding the important information. That was quick without a calculator. Okay, anyway, so let's do one other. All right, so and you could use the calculator right away as long as you know how to find these still. The calculator can help, but I think just going by hand would be quicker anyway. So let's do number 1, 2, and 3 by hand again. Okay, so vertical asymptotes, again, is where the denominator equals 0. So x squared minus 4 equals 0. All right, so I'm going to add the 4 over. So adding the 4 over would give me x squared equals 4. Now, to get rid of a square, I could square root. The main thing is make sure you do plus and minus on the numerical part of the square root. That way we get x is equal to plus or minus, the square root of 4 is 2. So we have x equals plus or minus 2, which means we really have 2 vertical asymptotes. We have it at x equals positive 2, and we have it at x equals negative 2. Okay, so that's the biggest thing we want to make sure whenever we square root, make sure to do plus minus on the number part. All right, step 2 is to find the horizontal asymptote. So the horizontal asymptote is based on finding the degrees of our numerator and denominator. So I'm just going to write out the whole function again. And we can compare the degrees. So notice our degree down there is 2. Our degree up top is 1. Now it's not shown, but you could always put a 1 there. So the degree down below is bigger. So that means by our rule for horizontal asymptotes, it's instantly y equals 0, which again we'll see in our calculator too. Okay, and then the third thing is to find the y-intercept. So the y-intercept is always where you just let x equal 0. So it would be f of 0 is equal to 2 times 0 minus 1 over 0 squared minus 4. So 2 times 0 is 0, minus 1 is negative 1, 0 squared is 0, minus 4 is negative 4, and then it would simplify to be 1/4. Okay, so our y-intercept is 0 and 1/4. Okay, so there's our important information, and just like the last one, let me go ahead and sketch this out. This time I'm not going to put any tick marks on our axis, I'm just going to do it blank. So here's our x and here's our y. But I could still at least approximate a little bit. So let me do our asymptotes again in the purple. Let me box those. Okay, so x equals 2, I'm just going to say is about here. And let's label it. There it is, x equals 2. And then the x equals negative 2 is, we'll say, about here. There we go. And then y equals 0 is right here. Okay, so let me mark it right there, y equals 0. Okay, so there's all of our important information. So x equals numbers are vertical lines, y equals a number is a horizontal line. And then our y-intercept we had as 0 and 1/4. So I'm just going to put that there for now, and then we'll label it once I have the final picture. All right, so now is where I want to use my calculator. I'm just going to hit X on this, and then we're going to type it in exactly as we see it. Here's where we want to use the parentheses for our numerator, divided by parentheses in our denominator. Oops, -4, like that. Okay, so there we get this picture. Okay, so notice that it does this curve through the x-axis, so I probably want that point. 0.5 and 0. There's the 0 and 1/4 that we found. Okay, and then now I'm just going to create the sketch that looks something like that on here. Okay, so this is why I didn't want to do it to any scale, because I do want just a quick sketch. All right, so now I'm going to complete this in my blue color. So these asymptotes again tell you the behavior of what the graph is doing, and we could see it. So it looks like this is going vertical. So that's where the asymptote is helping us. And then the end behavior is going flat, horizontal, and that's where those asymptotes were helping us. Okay, so but let's go ahead and make sure I still plot my point. Okay, so I do want to plot my point 2. Okay, so it looks something like that, and let me label that. So this was our 0 and 1/4, and then this was the 0.5 and 0. You could label it using a decimal. I'm going to change it to a half. I know 0.5 is a half, so I'm going to do a fraction as well. Okay, so there's those 2 points, and then the rest of the graph was something like this to the right and something like this to the left. There we go. Okay, and as needed, if I need other points, I can go to my wheel and click the table and find. Notice at -2 it's undefined. Okay, so I could use other values though to get other points. Okay, so that's about it though. Okay, so there's our quick sketches using a calculator. Looks good, I think. Okay, so if you do have questions though, please let me know. Otherwise, thanks for watching, and I'll see you again next time.